Hello. In this video, we're going to show a quick demonstration of using an Ansible playbook to spin up a few servers in Amazon GovCloud. It will also demonstrate the ability to patch those servers and work with them in a larger cluster of servers that have related or similar functions. So let's get started. You can see here, I've got my Amazon web interface showing I had one test server that is in a terminated state and but nothing else running. I've got the inventory file that Ansible is going to use. I've defined one group that's called the on-prem group. This is a list of servers that are fairly static. In my case, there are two lab boxes I have that want to pretend are part of this larger cluster. Got a second group here that's called the EC2 hosts group. And as you can see right now, it is empty. But as we build up the machines in Amazon, that host group will get uh, configured internally within the playbook and be used later for other tasks in the playbook. Then finally, we've got this all host group, which combines the servers in those other two groups. So we have one name to reference them by. So when we want to make a configuration change to all those servers at once, we can just reference that one group. And regardless of the contents of those, it will connect to all of them at once and keep them all consistent. The playbook itself is broken up into a few sections. The main first section we're going to look at here is the one that actually sets up the staging instances. It is going to use this variable here to define the type of servers they are. That's just an internal name. And then how many of each we want. So I'm going to spin up one web and one mid-tier server in this example. I'm not going to spin up any database servers just yet. And then it goes through and it pulls in some of the Amazon credentials, which are defined securely in another file. The main work for this part, showing the spin up and spin down, is this section here. It's going to call out to Amazon using the EC2 module within Ansible, and it's going to ensure that we have exactly this number of one web server and one mid-tier server up and running in our available in our cluster. It's going to add them to the inventory file. It's going to do some waiting here, wait for them to boot up fully. Down here, it's going to stig them, which is securing servers so that they meet the common spec that we need. That takes a little bit of time, but when it gets done, then it sets up, does some other tasks, which could be common tasks. In this case, it's setting the host name and installing a few other packages and making sure they're fully patched. So, and then finally, it reboots them if they were patched. It gathers some facts and shows the uptime. So it shows that it's doing some work and would be able to do pretty much anything it wants to on the server. So let's go ahead and get started by running the playbook. The playbook shows a debug output showing the number of each server type it wants to build. So we told we want one web server, one app server, and no DB servers this time. Hit refresh my Amazon console. We see that it is starting to spin up a server right here. Got a public IP address of 145. So that'll takes a minute or two for that to get spun up. You can see here it's already got that one up and ready. So if I hit refresh, we see that that was the web server. It stood up and it's in a running state, and it's now standing up the app server, the mid-tier server. And playbook got done with that. So we got two servers up. It now is waiting for all of the servers to come online. That first one probably came up fairly quickly and was ready right away, or ready as soon as it got to that point. The second one stood up, still in the booting phase, so Ansible is waiting. There, it looks like it got onto it. It now is able to get some information about it, and it's gathering facts. Now, if you notice that the number of servers it's working on is 4 of them, that's because we got the two permanent on-prem servers that we set up, and it's doing the work across all of them, so we're keeping them all consistent. In this case, it's running the Stig script on each of them, and it's going through, making some changes. Little word if you haven't seen Ansible output before. The colors do mean something. Green and yellow effectively mean things were okay when it got done. The blue here is a step that was skipped, probably for a configuration reason, like didn't have the right, wasn't the right version of the operating system or other reasons. In the case of our playbook here, we have commented out a lot of those so that it goes by them quickly and makes this demo a little bit quicker. But we do have a few here at the end that we'll get to. The other color you might see, and hopefully we won't see it, but you could see, is red. Red means that Ansible tried to do something on the server and failed for whatever reason. Maybe it didn't have permissions to do it or other fail scenario. The good thing about Ansible is if you can think of it more as a checklist and not a programming language per se. Think of it as I've got a checklist of a specific state I want to put a system in. So if we go down here to the bottom of the playbook, we see that this section here, it's got a list of packages and it wants to make sure they're installed and at the latest version. So it's going to run through all those. And if it tries to install those packages and they're already at the latest state, it might come up with a green output saying, hey, yep, we're all good. If it runs and it finds that a package or two were not up to date, but it could install them properly and the package manager didn't report any errors, then it'd be a yellow. If it would try to install it and the package one of the packages would fail, it would return a red and it would stop working on that system from that point on. So think of it as a checklist. It's going to get them into a state where the package we gave it as the lists are all at their latest state. If it fails, it's going to quit. So it's like a pre-flight checklist or a checklist you might have if you're going on vacation. So as we can see here, we are now down to that add base apps and got all four of the machines. We'll probably have to get some packages installed. What we will probably see, should see here when we get to the fully patch the system, the two ANS VM servers that are part of the on-prem group, those have been recently patched and updated. So they should come back green, meaning there wasn't anything for the playbook to do. The two that we just built in Amazon are going to be a little bit out of date probably. So there will be some packages that needs to fully patch. And there's the green output, as mentioning. We've got the VM1, VM2 servers that were fully up to date and no work was needed. Or it's taking a little bit of time. That must mean that the other servers, the two Amazon EC2 machines, do have some packages to install. They're normally not too far out of date, but always best to keep them fully patched. So here we see that the 44 box got something applied to it. And so did the 208 box. So the other thing here is this patch status variable, or it's registering a variable called patch status. That's used in the next place that when the package manager runs, if it had to make any change in the packages, meaning it installed an update, it sets the changed flag. Well, we're checking that here, and on each of these machines, if that changed flag was set to true, it would just do a simple reboot of that server. So here we see that these two boxes, the two EC2 images, did have some sort of change on them. That's what the yellow means. So now the reboot phase came through, and since we didn't have any change on the on-prem boxes, they are blue. They're getting skipped. Wasn't any need to reboot them, but the two EC2 images are getting rebooted. There we go. So they've come back up. The reboot module does wait, and there we see that we've got the machines there. We've got some uptime. We see the two on-prem boxes have an uptime of 22 minutes, and the EC2 images have an uptime of 0 since they literally just got rebooted a couple steps before. So this demonstrates the building of servers in Amazon EC2. We've built a web server and app server. In a later demo, I'm going to continue on and we will show the scaling up and scaling down of this environment to show how that works. Thank you very much. Have a good day.